Alright guys, we're going to talk about the triangle proportionality theorem today, and that's going to be on pages 104 and 105, so you will label 104 and 105 12.1 triangle proportionality theorem. Now, the video you're fixing to watch is from last year, so don't pay attention to the pages. It is in your notebook. It's 104 and 105, okay? Now, I'm going to tell you, because the video from last year does not tell you, where each piece comes from in your notebook, okay? And then you're going to glue them on those pages, work through it, pause as much as you need to, and ask for help as you need to. So I'm going to go ahead and flip to 104 and 105 and talk about where each piece is. So you'll have a total of 6 pieces, okay? You'll see these in there. The first one comes from 632. The next piece, 633. The next piece, 634. Okay, so there's 1, 2, 3 pieces on 104. Your notebook or the video shows you that. It just doesn't tell you where the pieces come from. On 105, you'll also have 3 pieces. 634 again, 635, and 635. Okay, so those are all the pieces. Yes, you can see the notes are already done in this one, but I wanted you to see where each piece comes from, okay? Then you need to actually follow along with the video to understand what the filled out notes mean, okay? So go ahead and watch that. Then you will start on a book assignment for this lesson.
All right, we talked about similar triangles like last week, and we talked about how the small triangle will be proportional to the large triangle, right? Well, today we're talking about how if you have parallel lines, which is what the triangle proportionality theorem says, if you have parallel lines that intersect a triangle, then the sides that are intersected are actually proportional as well, because they have that angle here, and because when we proved that the similar triangles were similar before, we used like corresponding angles, so that's how you can actually prove that. But so the triangle proportionality theorem says if a line parallel to a side of a triangle intersects the other two sides right here, E and F, then it divides those sides proportionally. So it gives us the picture here, and what it's saying is that AE, which is here, and it's right here in this proportion, is similar to EB, so therefore they're in that proportion there. So AE over BE. And likewise on the other side, AF over FC. So yes, we could prove that the small triangle is similar to the large triangle. However, if they are parallel here, then I know that these are in proportion to each other. So we're going to use that to solve these problems. Alright, letter B says we're going to find PN. It's important that we notice, are these parallel? Yes. Okay, so then we're going to highlight the exact same pieces that we had from up here. We have from the vertex to that parallel line, from the vertex to that parallel line, and then we have these other pieces here. And since they're parallel, they should be in proportion to each other. And we are looking for PN, which is right there. How are we going to set up a proportion to find that in? Okay. I'm going to make sure it doesn't actually matter. We could do exactly what Keely said and do 3 over x, 2 over 5. You can also do, if you're matching colors, x over 3, 5 over 2. They are both the exact same thing. So I'm going to do what she said, 3 over x, and she's getting this x right here. So she replaced p in with an x. So 3 over x equals 2 over 5. The point is it's important that your colors match across here. So 3 and 2, and x and 5. Like I said, you could have had x over 3 and 5 over 2 as well. Alright, how do we actually solve this though? Okay, cross multiply. What is 5 times 3? And that's equal to, so divide by 2. What is Pn equal to? Okay. Number 5 and 6 are similar, so try those on your own. So whether you wanted to use colors or not, it was up to you, but do we have parallel lines like we're supposed to? Yes, so we can do this. Alright, what did somebody set up on DG? Say what you said again. Equals x over 40, and we're looking for DG. So that's x. Right. Likewise, cross multiply. What's 24 times 40? Okay, and what's 32 times x? Yeah. Okay. Then you divide it by 32. What is dg, or x, equal to? Okay. There are other ways to do this, by the way. Yep. If you find out what 24 over 32 is, it's like 3/4, I think. And then you could have seen that this also needs to be in 3/4. That's just finding the scale factor between them. It's the same process, and if you like that better, you can do that. It's fine. It does not matter. It's all the same concept. Alright, if you set it up, though, with a proportion on number 6, what did you do? Cross multiply 50 equals 8x. Divide by 8. What is x equal to? 6.25. Okay. Alright, so that's the triangle proportionality theorem. If you have a parallel line, it's parallel to the base of the triangle, then the sides are divided proportionally. We are going to talk about the converse of that theorem. Do you guys remember what a converse actually is? Yeah, it's like it flips it around. So if the actual theorem was if you have parallel lines, then the sides are proportional, what's the opposite of that? Okay, so now we're going to do the opposite. We're going to show that if we have proportional sides, then we have parallel lines. So we're actually proving we have parallel lines now. This is still the same image. It's the same picture. It all works the same way. So here's what we have. We still have that same picture, and they went ahead and told us that AE over EB is equal to AF over FC. And if that is true, then we have parallel lines. That's what we're doing this time. If that is true, then that means EF is parallel to BC. So this, while example 4 says verify, it is a proof, it's just not a complete formal proof. We're just going to make some statements to show it is. Okay, so example 4, it says, I want to prove that MN is parallel to KL. So in order for those two to be parallel, what has to be true? That was a lot of mumbling. What? Which size? MJ and what? Yes. So MJ over KM. We'll figure out what that is. we'll need to figure out what Nj over Ln is. And if those, in fact, are equal, then we have parallel lines. So Mj is 42, and Km is 21. And Nj is 30, and Ln is 15. What is 42 over 21 reduced to? 2. If you have it the other way around, as long as both of them are the other way around, you were fine, so you would have had 1/2 instead. What is this one reduced to? So they are equal. Proportional. They are proportional to each other. So since Mj over Km is equal to Nj over Ln, we know that Mn is in fact parallel to Kl. There's my little sentence. This is the work that goes with it. There's the sentence. Like I said, again, it could have been flipped. It would not have mattered as long as both of them are that way. What do you need to do for letter B before you start solving it? Yeah, and how do you find AD? 36 minus 20, so it's... And how about B, E? 27 minus 15, you said is 12. Alright, I want you guys to do letter B and number 9. Alright, letter B, after we found these pieces, what did you guys set up to determine if they were parallel or not? Okay, 20 over 16 and 15 over 12. What did those reduce to? It reduced to what? 1.25? If you did it the other way around, what'd you get instead? Yeah, but they were the same, right? Okay, so are these parallel? Okay, so since I'm using the letters we use, CD over DA is in fact equal to CE over EB. We know that DE is parallel to AB. Okay. Number 9, very similar. What'd you guys set up? Okay, we'll do it that way then this time. What'd you get when you simplified your numbers? If you did it the other way around, you got a different number, but they were still the same proportion. Okay, so they are proportional. I'm going to go by what we have here now, RT, since RT over TV is equal to SU over UV. We know that TU is parallel to RS. Notice it did say verify, not prove or disprove. That's why they should have been parallel. That is it to proving these. You've got the actual theorem and you've got the converse. I'm going to tell you what your assignment is. page 637. Through 10.